Morning children. Today we have to start the topic numerical based on the resistance on Guru-Shishya talk channel. Children, first you see the video and now after that everyone like this channel and subscribe my channel Guru-Shishya talk channel. Now we discuss about the topic combination of the resistance, how to connect the resistance, how can find out the equivalent resistance between the 2 points. Children, now see this formula everyone knows, R equal to R1 plus R2 plus R3 plus and so on plus Rn, and everyone knows it is the combination for series. That means in series if the resistance is joint, then the formula is R equal to R1 plus R2 plus R3 plus Rn we have to use. And according to this formula, always we have to find out the maximum resistance. If you want to find out the maximum resistance, then always use the series combination of the resistance. And if you want to find out the minimum resistance from the given two resistance, then always you have to use the parallel combination of the resistance. And now see the formula for the parallel, 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus and so on plus 1 by Rn. In parallel, if you want to find out the minimum resistance, then always you have to use this relation for the parallel combinations, and it is used only for the minimum resistance. And children, now we see here the resistance R dash equal to N square R. Everyone remember this formula. And why we have to use this formula R dash equal to N square R? If any wire is given to you of length L and cross section area A, if the resistance, we have to find out the resistance of the wire if it is stressed n times. If the wire is stressed n times, then the final resistance becomes, suppose that it is the L dash, and L dash equal to given NL. That means the length of the resistance wire becomes n times. It is given the condition. In the place of n times, it is given the 2 times, 3 times, 4 times. Then always you have to use the formula R dash equal to N square R. And the derivation is everyone knows. The resistance becomes N square times if the resistance wire is stressed n times. And if the resistance wire is cut in n equal parts, n pieces, then the resistance of one small piece is equal to R dash equal to R by N. It is the resistance of the one parts. If any wire is cut in n equal parts, then each parts of the wire have a resistance of 1 by n times of the initial resistance. Children, after this, use this formula, series combination, parallel combination, and the resistance of the wire when it is stressed n times. We have to utilize all this formula in the numerical, and now see how to solve the numerical problem which is based on this formula. Children, suppose that one wire is given to you of length L. If wire of the length is given L equal to 5 meter and the cross section area of the wire is given 10 centimeter square. If the wire is stressed in this way, then the length becomes 20 meter. Then find out the resistance of this wire. How can find the resistance? Now see what is the relation between L and L dash. Everyone knows L dash equal to NL, N times of L. Then L dash is given here 20 and into initial length is given 5. So N equal to 4 times. That means the length of the wire becomes 4 times, and everyone knows the formula R dash equal to N square R. Then what is the effect on the resistance? Then the resistance of the wire becomes N square times. That is R dash equal to N is given 4. That is 4 square, and into resistance, suppose that the resistance of the wire is given R. Now it is 16 times. The resistance becomes 16 times. If the length of the wire becomes 4 times, then the resistance of the wire becomes 16 times. And after that, there are the different conditions given to you. Suppose that after stretching the wire 4 times, we have to prepare the circle with the help of the stretched wire. And in this question, find out the resistance across the diameter. Across the diameter. Suppose that this is the point A and this is the point B. Find out the resistance across the diameter. So everyone knows the resistance becomes 16 times. So it is the resistance of the whole circular loop, and everyone knows it is equal to 2 pi r. Suppose that r is the radius of the wire, radius of this circle, then 2 pi r equal to 16r. 2 pi r equal to 16r means it is not a length. I am saying that it is the resistance of the whole wire is given 16r, and 2 pi r is the circumference. It is not equal to, it is the resistance here, the 16r. So across the diameter, you see here the wire is divided in 2 equal parts. It is the above part here and it is the lower part. So it is divided in the 2 equal parts. So the each parts of this circle have a resistance of half of the 16r, that is 16r by 2, and it is 8r. And now the resistance of the lower part is also 8r. So there are the two resistance which is joined across the point A and B. One is 8r upper part, and lower part is also have a same resistance 8r. But across the diameter point AB, the both resistance, it is joined in parallel. And everyone knows about the formula of the parallel combination of the resistance. The equivalent resistance, suppose that it is R dash, 1 by R dash equal to 1 by 8R plus 1 by 8R, and it is equal to 2 by 8R. It is equal to 1 by 4R when it is divided, and R dash equal to 4R. So the answer becomes 4R. So children, now let us see how to solve this problem. In any question, if it is given the wire is stretched n times, then always you remember the resistance becomes n square times. If the length becomes 2 times, the resistance becomes 4 times. Length becomes 3 times, the resistance becomes 9 times. Length becomes 16 times, so you know the square of the 16. That is R dash equal to n square R is the formula. And here it is given the question, length of the any wire is given 5 meter. Then after stretching, the length becomes 20 meter. So now see how many times the length increases. So L dash equal to NL. Let us consider the n times length increases. So now we have to find out the n equal to 4 times. And now using this formula, R dash equal to n square R. Now R dash equal to n is given 4 square 16 times. And if this stretched wire is form a circle, and find out the equivalent resistance across the diameter point. So the whole wire is divided into two parts. One part, above part have a resistance 8R, lower part have a same resistance 8R, and now the both are joined in parallel, and after that we have to apply the combination of the parallel resistance, and now it is the result R dash equal to 4R. And suppose that if this wire is also connected in the different shape or in the same shape, if find out the resistance in the question, it is given find out the equivalent resistance across the point. Suppose this is the point B and this is the point C. Find out the equivalent resistance across the point BC. How can find the resistance across the point BC? So children, you see the resistance wire is divided in the 4 equal parts. So one parts have a resistance of 16R by 4 and it is equal to 4R. The 4R is the resistance of each part if the resistance wire is divided in the 4 pieces here. So now see here, the across the BC, 3/4 part have a resistance and 1/4 part have a resistance of 4R, and 3/4 part is the 3 times of this is, it is 12R. So 12R resistance and 4R resistance both are joined in parallel across the BC, and now apply the formula 1 by R dash equal to 1 by 4R plus 1 by 12R. Now it is 12R is the LCM, 3 plus 1, 4 by 4 12R, and it is 1 by 3R, and resistance becomes R dash equal to 3R. So in this condition, the resistance across the BC, if for this given question, it is equal to 3R. And children, now see, if this wire is joined in the different shape, now see the another shape, how can solve the questions? If this wire is form a square, and everyone knows in the square each part, that with the each side of the square have a same length. So the resistance finally it is equal to 16R, and if it is divided in the 4 equal parts, then each parts have a 4R resistance, 4R, 4R, 4R and 4R. And suppose that in this question, find out the equivalent resistance across the point AB, or find out the resistance across the any one side of the square, or find out the equivalent resistance across the any diagonal, that is AC, from the same question. That means the resistance of the wire becomes 16 times after stretching the wire, and now it is divided into the 4 equal parts and it make a square. Each part of the square have a 4R resistance. Now find out the resistance across the AB. Children, now see across the AB, it is the 4R single resistance, and here it is say the 4R, 4R and 4R. All 3 4R resistance are joined in series. So that is 4R plus 4R plus 4R, it is equal to 12R according to the series combination formula, R equal to R1 plus R2 plus R3. So across the point AB, all the 4R 3 times it will be joined in series. So resistance becomes 12R, and 12R and 4R both are joined the parallel across the point AB. And now apply the formula for the parallel combination. So resistance 1 by R dash equal to 1 by 4R plus 1 by 12R. It is 12R, it is 3 plus 1, 4 by 12R, and it is equal to 1 by 3R, and now the R dash equal to 3R. So in this way we have to find out the resistance across the any one side of the square for the given question. Children, and now if we find out the equivalent resistance across the any diagonal, how can find the resistance across the diagonal? It is the diagonal A, C, across the point A and C, or across the point B and C. So children, across the point A and C, you see AB plus BC, there are the 2 resistance joined in series. So 4R plus 4R both are joined in series. So the equivalent resistance 4R plus 4R, let us consider it is R1, 4R plus 4R, it is 8R. And the same resistance for side AD and DC, and it is equal to R2 equal to 8R. That is 8R and 8R both are joined in parallel between the point A and C. And now apply the formula for the parallel combination. 1 by R dash equal to 1 by 8R plus 1 by 8R. And now it is equal to 2 by 8R. 2 1 ja 2, 2 4 ja 8. It is equal to 1 by 4R. And the resistance becomes R dash equal to 4R. So in this way we have to find out the equivalent resistance across the diagonal, across the any one side of the square. And after that you see the another shape of the resistance. Suppose that the 4 times after stretching the wire 4 times, then the resistance becomes 16 times. And after 16 times resistance, we have to divide the resistance wire in 4 equal parts. So what is the resistance of each part? It is equal to R dash by 4, and R dash is 16R by 4. It is equal to 4R. So the resistance of each part is equal to 4R. When the wire is divided after the stretching the 4 times, it will be divided in the 4 equal parts. Then the each parts have a resistance is 4R. And if the 4 pieces is arranged in this way, one is the equilateral triangle in the form of equilateral triangle. Now see how many sides is given here? 1 2 3, but we have a 4 parts. So now another wire is connected in this way, CD, and everyone knows each parts have the resistance of 4R, 4R, 4R and 4R. Then in the question, find out the equivalent resistance across the point AC. Find out the resistance across the point AC. Find out the resistance across the point BD. Find out the equivalent resistance across the point BC. And find out the equivalent resistance across the point RAB. So there are the different conditions. You have to find out the resistance with the help of this figure. So resistance across the point AC. First you see the point A and C. Where the point A and C is given, you see it is the A, it is the point C. Children, between the point A and C, you remember, for this resistance, one terminal is connected at the point C, but other terminal is open. So no current is flow through the CD. So it is the useless for the resistance if you would have to find out the resistance equivalent across the AC. So CD resistance, that is this 4R resistance, is useless for equivalent resistance across the AC. Only how many resistance is useful? It is AC and AB and BC. So there are the 3 resistances useless. There 1 is useless and 3 is participate here in the combination of the A and C. Now find out this one. Across the point AC, you see 4R and 4R, all these 2 resistance are joined in series. So the resistance becomes 8R, 4R plus 4R. And now 8R and 4R both are joined in parallel across the point AC. So the final result becomes 1 by R dash equal to 1 by 4R plus 1 by 8R. And it is equal to 8R is the LCM. It is 2 plus 1, 3 by 8R. And now R dash becomes 8R by 3. It is the result across the point AC. Now find out the resistance across the point BD. Across the point BD, where the point BD? You see here, B and it is D. And children, across the point B and D, first you have to find out the equivalent resistance across the point BC. So there are 4R and 4R both are joined in series, it is 8R. And 8R and 4R both are joined in parallel. And so the resistance becomes 8R by 3. 8R by 3. And 8R by 3 resistance are is joined with the 4R resistance in the series combination. So now the final resistance becomes 1 by R dash equal to 1 upon 8R by 3, 8R by 3 plus 1 by 4R. 1 by 4R, and it is equal to 3 by 8R plus 1 by 4R. And equivalent resistance, find out. The LCM is 8R, and it is 3 plus 2, 5 by 8R, and R dash becomes 8R by 5. The equivalent resistance across the point B and D is 8R by 5. Now in the same procedure, we have to find out the equivalent resistance across the point B and C. You see that across the point B and C is over, and we have to find out the resistance across the point AB. So across the point AB, you see here the point AB, A and B. Across the point A and B, this resistance is useless. Only these 4R and 4R both are joined in series. It is 8R, and 8R is joined with the 4R in parallel. So the resistance becomes 8R by 3. As written, I think everyone knows about the numerical problem and how to solve this type of question, which is based on the resistance combination. In the next video, we have to solve the another problem which is based on the different combination of the resistance. So children, just you see the video, and after that you subscribe my channels and like it. Thank you to all of you.